Yesterday you learned what an equation was, and so today we're going to be solving equations. We're only going to be using addition and subtraction for this, but you have to go back to what we talked about for a definition of an equation, because all it is it's a balance, and the equal sign is like your body, and whatever's expression is on this side has to always have the same value as whatever the expression is on this side. And you're never allowed to be out of balance at any time. So whatever you do to one side of an equation, you have to do to the other side so that you're remaining in balance all the time. Now, the beauty about an equation is a lot of times we can make a pretty good guess about what the value of the variable is. Remember, that's our job. We want to know what this value of the variable, and that's solving an equation. So when I look at this, I know it's some number plus 16. This side has to equal 4 because this side equals 4. And because I know that this 4 is smaller than 16, I must be working with a negative number. So I could look at this before I even start to solve it, and I could think to myself, what could that number possibly be? I want to make some sort of educated guess. So when I look at this, I'm thinking maybe negative 12. But that's not solving the equation. So when we go to solve an equation, we always start on the side that has the variable, because our job is to get that variable by itself. And what we're going to do is we're going to use inverse operations. So I take a look at whatever's attached to the variable and I see plus 16. And I know that the inverse of addition is subtraction. So in order to get rid of that 16, think of it as a pan that has 16, say, marbles in it. I want to take 16 marbles away. So that inverse operation helps me reverse it out, but I'm out of balance. The second I did that, now I've taken something away from this side. It has to be taken away from that side. Otherwise, I'm not going to be in balance. So if I took 16 away there, I also have to take 16 away there. This is called the subtraction property of equality. It just simply means whatever you do on one side, you have to do on the other side. Well, when I had 16 things and I took 16 things away, they're gone. But what's still left on that side is this z. And when I have 4 and I subtract 16, I'm going to go into my negative numbers, which is fine. We should be expecting that. I get my answer of negative 12. It's what I thought was going to happen. Now, I want to make sure that that answer is correct. And so all I need to do is substitute in the number that I got back in to the place of the variable. So I'm going to take negative 12 plus 16. I know that this has to equal that because it's an equation. If I get it so that they're balanced, I know I'm correct. So the last step of solving any equation is you want to substitute the value back in to make sure it actually works. So think of it as a 3-step process. First, make a good guess of what you think the answer is going to be. Then use inverse operations to solve. Then substitute your answer back into the variable, see if it works. Now we can also do that if we have a subtraction problem. Again, what do I think the answer is going to be? Well, I know some number minus 18 equals 7. I'm thinking it's just going to be 25. But now I got to solve it. So again, I go to the side that has the variable. I look at whatever's attached to that variable, and I'm going to use my inverse operations. The inverse of subtraction is addition. So if I'm thinking of that balance, I'm going to add things in. Remember, I'm trying to get it to come to 0. So I'm thinking I have 18 reds. Well, if I need to get it back to 0, I have to add 18 blacks to make 0 pairs. Uh-oh, I'm out of balance. So in order to bring this back in balance, which is the definition of an equation, I got to add 18 to that side. This is the addition property of equality. Whatever I do to one side, I have to do to the other. These cancel out because it's like 0 pairs. I'm left with W, and 7 plus 18 is 25. That was what my guess was. That's what I was thinking it should be. But now I want to make sure, so I'm going to substitute that back in, placing 25 in for W. 25 minus 18, 7. That equals 7. That equals 7. I must be correct. Because remember, definition of an equation, One side must equal the other, never out of balance. Now sometimes you're going to have to do a little work, and you can only solve for a variable if you have one thing attached. So 2 lessons ago I showed you that whenever we have subtraction, we want to change that to plus the opposite, because I can see I need to gather some like terms here. So I'm going to rewrite this problem. I see that subtraction, that's going to become plus -3. And I only do that so I can gather my constants together. So now I'm going to gather these the constants. I have 15 reds and 3 reds, therefore I have 18 reds, or -18. Once I get it to the point where I have a variable and then one set of constants attached to it, now I'm ready. Now again, I'm going to want to use inverse operations, starting the side that has the variable. So right now, I see I have -18 or 18 reds. To get rid of those 18 reds, I'm going to add 18. But now I'm out of balance, so to pull it back in line, I'm going to add 18 on this side. These cancel out. I'm left with a positive variable. And -9 plus +18 is a +9. Now notice, I didn't do my mental check. I got so caught up in just pulling my terms together, but if I go to check it at the end, I should be able to tell if I got it correct. So I'm going to come here, I'm going to substitute 9 in for the -b. So this side equals -9, that means this side has to equal -9. So -18 plus 9, -9 equals -9. I know that must be correct. So the one step you don't want to miss is the check, because that always guarantees that your answer is correct. These are the types of problems that you're going to have today. I, again, have worked all the problems for you, so always be looking at my work as you're working through this. Remember, if you need to gather like terms, change those subtractions to plus the opposite. That's kind of the key in order to gather them correctly, and then the rest of the problems should work out well. I will be back tomorrow, so any questions that you have, don't worry about it. We'll talk about it when I get back. I just want you to try this, have fun with this. Please solve it algebraically. I know a lot of these you could do in your head, but I need to see the inverse operations, because we're not going to stay with easy problems like this for long. And so you're going to want to be able to prove to me that you know how to solve algebraic equations, so that when we get to the harder stuff, you can do it. Good luck. See you tomorrow.